Hello everyone, welcome back. Today let's solve the 28th top coding entry question from 48 top coding entry questions curated by Leetcode. We'll solve this problem using Python. This problem is related to a tree. So given a root of a binary tree. What is binary tree? A tree which contains maximum 2 children nodes. So given a binary tree, so what we have to check whether if it is a mirror of itself or a symmetric tree. Example, if you see, when you actually, if you are here, like, if you see this tree and then if you put the image right, in front of that tree, so you will see, it's basically you check whether your image of yourself, right? So when you standing in front of the your mirror, so you, if your left hand becomes right hand and right hand becomes left hand, right? So you will see when you stand in front of your in front of the mirror. So that's the same as this symmetric. So here you start with root. This these are mirror, fine. So here there is a, this is in the left side should be equal to the right side. So the left of left should be equal to the right of left, right of right, and left of right should be equal to the right of left. So this is how the image or the symmetry of the tree looks like. So if this is the values are similar, so the values are similar here, in this case this is the symmetric, so the values are similar, so one is fine. So these two are symmetric, these two are like the left is equal to the right of right. Similarly, left of right is equal to right of left. So this is symmetric tree, and then this is, we just have to return if it is symmetric. If it is not, so here if you see here, so this is left and right. So if right, and if this was here, so we can say that it would have been asymmetric. So but it is not, so it is right and right, it should have been right and left, so it would have been symmetric tree. Or maybe if this left of left, this if this 3 was here, so it would have been a symmetric tree, but it is not, so that says it is a false. So what I'll do is I'll simply start writing the code given a root of a tree, right? So what I'll do is, if first of all, if it is an empty tree, if root is empty itself, if not root, that's a condition, return true. I mean, empty tree is a symmetric tree automatically, there is nothing here, so I'll simply return true. This is the first condition. All right, so else what I'll do is I'll write a function called def is mirror. I recursively call here is mirror. I'll simply call this function, self is object. I'll simply pass this left and right of the, so basically I'll call this function recursively. I'll call this function recursively for the left side, I'll call recursively for the right side, left side and right side, and left side recursively. Basically I'll call this function, and then checks it's by passing left and right side of the root tree. I'll recursively call, and then if the values here, for example, if the left side is equal to the right side for the first time, left side is equal to right side, I basically check yes it is true. Then again you call recursively if left side of left side is equal to right side of right side, I'll recursively so on so call, and here left side of right side equal to the right side of left side. I'll basically call recursively the same function and then check its corresponding values. If everywhere it is matching, then I'll return true. If not, I'll return false. Anywhere is matching, I'll return false. If, for example, let's say for the first time only one node is there, then I'll return true, right? I mean, it's a symmetry of itself. So basically, inside this function, if not left, for example, left tree and both left tree and right tree, imagine both are null, right? Left tree and right tree, if not left and not right, basically both are return true. So what I'm saying is, so I'm just saying for the first time, I'm just like writing the edge cases, right? If for example, if I pass only one, so it is a symmetric of in itself. So if not, if this and this both are not there, left and right both are not there, then I'll return true, because it's only one tree, so one node, so you simply return true. If not, let's say if there is only any one is not null, right? Any one is null. If not left or not right, if any one is null, I'll return false, because it's not a symmetric. Return false. These are edge cases. They are not main logic. So if any one of these is not if it is null, right? So this, you have a tree, so left side is there, but right side, imagine there is no node, so then I'll return false here, because it's not a symmetric tree. So finally, the main condition is here. I'll call this function again and again. Return. So I'll basically call left val equal, because it's a tree. How to construct a tree? What is tree? The different nodes. How do you farm? How to debug? I explained in valid binary search tree and maximum depth of a binary tree. So please watch my previous videos to understand how to create your own tree, and then how do you debug, how do you traverse through the different trees, and how does it looks like left side and right side, how each node looks like, what's the different address. So detailed I've explained in these two examples. I request you to please watch. All right, so I'll basically check. I'll basically have to return true or false, right? If this left of value, which is this left of value, val is this, right? Node is equal to right of val is a variable, so I'm basically checking the left when I'm traversing t. So left side is this and right side value is this for the node which we are in, and this is the first condition. Now I'll iteratively check, and what I'll do is, this is another thing, what I'll do is I'll call the same function again for the first time. Once I reach here, once I reached in the left side, I again further have to reach here, right? Once I reach to the right side, I'll again further have to go further, right? So what I'll do is mirror. I'll set left of left should be equal to, I'll call again left of left, I'll call left of left, comma, because I need left, and right of right, further recursively call right of right, and last condition, and is mirror. This left of left should be equal to right of right, plus left of right and right of left, right, that is also should be equal, right? So I'll again call left of right, recursively call left of right and right of left. That's all. So basically I'll call this function. So I'll return self is the object. I have to call function name with the object. I'll pass the roots left tree, root dot left, and because we have given root, right, so root dot right. We're almost there, and I think we also have to call this function self, right, because we have to call with the object name. Object is the class name. That's all. I think we're almost there. All right, so let's see what we get. I think we're almost there. Did I miss anything? If not, root self mirror, root left, root right, root left. I'm calling this function. If not left and not right, return true. If not, or return false. Left of value equal to self mirror. Okay, let's see the syntax, whether it's correct or not. Yeah, it's correct. So this is a valid symmetric tree. Basically, it's a symmetric tree. Let's run the other test cases. Yeah, it got accepted. So that's all, guys. Please, what I would suggest is, please watch this video, debug this code, create your own tree node, and put the debugger and debug the code and see how at each stage how this mirror function is getting called, in each iteration how recursively this function is getting called, and then see the different values around, how the address looks like. Please watch these two videos and you will understand how to put a debugger and how to debug the code in VS Code, Visual Studio Code. That's all guys. Thank you for watching. See you in the next video.